Hey, hello, it's me, John Park. It's time for John Park's Workshop on a Friday. How about that? Thank you for joining me on this weird day. Fridays are weird. Usually I do the show on Thursday. Various circumstances prevented me from doing it yesterday, so I was able to move it to today. Let me know how that goes for you. I know at least one person had to wake up from a nap to watch the show. Thank you, Thin Man. I appreciate it. Hey, Bug Lugs from the UK. Welcome. Thanks for stopping by. And hi, Dave Odessa over in our YouTube chat. You saw me speaking to these fine folks right here in our... Whoa, what's that sound? Oh, that was my Bluetooth speaker shutting itself down. Thanks for announcing yourself. What was I saying? Hey, look, there's the Discord chat. If you're wondering where the chat is, maybe you're over on Facebook or somewhere else, LinkedIn, Twitch, and you don't see any chat, you can head over to our Discord server, which is at adafruit.it/discord. And that'll get you an invite right into our Discord server. You can look for that channel right there, live broadcast chat channel. There's lots of other channels too. I think we have over 30,000, maybe more, 35,000 users. I don't think it says over there anywhere. And we have a bunch of channels for help with different software and coding languages and topics and hardware, as well as pet photos and other good things like that. So head over to our Discord live broadcast chat channels where it's happening during the chat. So hello, C. Grover and Paul Cutler and Jeff. Thank you for stopping by. Thin Man, yes. Hey, Jim Hendrickson. Hey, Todd Bott. You could have been taking a nap. Shh. Don't think about it too hard. Stay here with me. Dave Odessa says, I thought this was Thursday. Look out. I hope I wasn't your clock, because I switched it up this week. Let's see, is that camera might be doing something suspicious. We'll see when we get over there. So we got lots of cool stuff happening on the show today, I think. I'm excited about it. So first of all, what are we going to do? I've got a coupon code for you if you want to buy some stuff and get a little discount in the store. I've got a recap of the product pick of the week. I've got a CircuitPython Parsec, one that was suggested by C. Grover. Thank you for the suggestion. I have a gear report, a new piece of gear I got, and it is a cool sampler from Teenage Engineering. I want to show just a little bit about that. I haven't played with it enough to say anything intelligent about it other than show it to you a little bit and show you the very cool Lego Technic integration that they did on the case, which I love and I wish everyone would do. Just make things with Technic pin holes and we can take it from there. Then I've got my PCBs in. You may remember a couple of weeks ago I was designing the what I've renamed the Faderwave, but that is my 16 fader board with a itsy bitsy connected to it and some DACs and an ADC or vice versa, some ADCs and a DAC, headphone out, little RC circuit, little screen on it. PCBs came in, and I built up one board. I want to show it to you. I've got some software working on it, and I'm going to do a little revision, but it actually works as is, which is great. So I'm just trying to refine a few things. And this one is just going to be a board that you could download or just have made for you at a PCB house if you want. It's not going to be an Adafruit product. Someone says they can't hear me. Dexter, what's going on, Dexter? Are your speakers on? I see my microphone levels reacting as if I'm making sound. So maybe... Oh, all right, Dexter dropped the message. Okay, sounds like you can hear me now. Yay! So that's going to be the show. Let's start it off with, I said I've got a coupon code for you. This is the coupon code today, Knockout. Knockout will get you 10% off in the store. Head on over to Adafruit.com. It looks like this. Go there. Go to Adafruit.com. Throw some stuff in your cart, your shopping cart, like a big long TFT display if you want. You can do that, and you'll get 10% off. It'll cost $2.19 or 20 cents less. 10% off on your order, and not only can you use that coupon code to get yourself a nice discount, but if I can find my browser, if you go to adafruit.com/free, you can see what some of the promotions are for spending more money. So if you spend $99 or more, you'll get a free PCB coaster. This is the very cool Adafruit PCB coaster. You can spend $149 or more, you'll get the coaster, and you'll pick up a KB2040 microcontroller board, which I'll actually be using in my CircuitPython Parsec today. It was a board that I had handy. If you spend $199 or more, you'll get free UPS ground shipping in these continental United States, and the KB2040 and the coaster. And if you go all the way up and spend $299 or more, you're going to get a free Circuit Playground Express and the ground shipping in the continental United States, and the KB2040 and the coaster. So you don't have to do anything. It'll tell you in the cart. You don't need a coupon code or anything for that. But you do need this coupon code, Knockout, if you want to get 10% off in the store today. So head on over to Adafruit and throw some cool stuff in your cart and make it just a little bit cheaper. Speaking of stuff from Adafruit, I've got my Tuesday show, the product pick of the week. I had a nice little product pick, an interesting one actually this week, I thought, the HUSB 238. And here is a little recap for you. It is the HUSB 238 USB-C power delivery breakout. When I plug in the HUSB 238, it is now giving me 20 volts. So I'm going to give it 20, or this 19.6 here, by plugging in the other end of one of those little pigtails there, and you'll see all of my little wireless LEDs lighting up. And so this one here has the 9-volt jumper set there. Now is going to provide us with 9 to my power input for the little flying faders here. You can see they are now moving around under the power of this power brick that's supplying 9 volts. It is the HUSB 238 power delivery breakout. That's right, that's what it is. I think we sold through those. We sold out of those. So it seems like a lot of people have big plans for using their cool USB-C power delivery for all kinds of things. I really like the idea of integrating that into different projects so you can then just plug in one common USB cable, and it doesn't matter if your device wants 12 or 9 or 5, 15, 18, 20 volts, who cares? One cable to rule them all. Next up, I've got a CircuitPython Parsec for you. Okay. For the CircuitPython Parsec today, I wanted to show you how you can use for statements with enumeration. So what does this mean? Well, if you think about looping through a for statement in the typical way, check out my code here. I've got a list. It's called some cool letters, and then I've got A, B, C, D, E, F, G, and H. So this little list, if I want to loop through this list and grab each of those values at each of those indices, this is a really common way to do it. I do it this way out of habit almost always. For I, little variable I, in range, the length of the list that I'm trying to enumerate through, or loop through rather, I will print some cool letters, bracket, I, close bracket. If I save this right now, you will see down at the bottom is going to loop through those letters. And I also have a little pause in there. This works great, but it's also a little bit clunky. It's not super clear to read if you're coming in and looking at someone else's code or your own code after a while. So with enumeration, you can instead do something much simpler like this. Check it out. For a cool letter in some cool letters, print a cool letter. It doesn't get easier than that. You'll see when I save that, the results are the same. It's going to go through and read out each of my letters there. But instead of having to talk about I and the position in the list, we can just simply enumerate through them with any variable we want. And I really like this because it lets you be descriptive with it. I'm not looking at I in there. I'm saying, oh, a cool letter, whichever one we're looking at the time. Now, if you want to use one extra feature of this, you can grab the count or the index, but really it's the count. Let me change this, in fact. Count, and print it so you can see which item number it is in that list. So when I save this, you're going to see, okay, 1, 2, 3, 4, 5, 6, 7, we have those letters. And so this is how you can use enumeration with for statements inside of CircuitPython. And that is your CircuitPython Parsec. Okay, you saw me pause there for a second because I got confused by why am I not seeing my 0 item in any of those? How come it's never starting on A? Did I do something wrong? I swear it wasn't doing that before. Someone, this is going to be a group project. Tell me what I've got happening in there. I'm going to wait for a moment. Something is up there. I swear it was working better before. What did I do? I'm going to check my notes. Hold on one second. What did I do? Maybe it's a Friday thing. Why is that doing that? Is it just a printing problem? Oh, you know, I've kind of run into some of these printing problems before. I wonder if it's just simply not printing that first one. Let me see. I think, yeah, we'll do it with this first one here. I'm going to wait for your notes to come in because one of you coders out there surely has spotted the error. Oh, start your code with Control-C, Control-D, don't save. Yeah. The USB enumeration time is eating the first prints. It's because I'm hitting save. Okay. Let's redo this. I'm going to redo the whole thing. This is going to make my life easier for editing later. Sorry. Okay. Take 2. You ready? I hope I am. In fact, you know what? Just because it'll be a little quicker to do it this way, I'm going to see if I can just add a little pause at the top here. Time, sleep. Let's say, will 1 second work? Yeah, nope. We need more time than that for USB to catch up. All right, how about 3 seconds? Is that outrageous? Okay, Todd, you win. I'm going to hit Control-D. Let's do it. Hey, it doesn't want to. What the heck? It won't do it, even with that time sleep. All right, I'll get rid of that time sleep. Did that do it? It did not. Okay, so now I'm going to Control C, Control D. Won't do it. Why? Weird. Weird is right. I swear I had something like this happen before. Is it this particular REPL? I wonder. Let's try. I'm going to open up a terminal window, and if I can remember how to get screen. Add a print at the top of your code. Oh, okay. All right. Print. Let's do that. Haha! That worked. What the heck? All right, that worked. Thank you, Todd. Can we make it descriptive? Enumeration. No, that'll be confusing. I'll leave it like this. All right. Did that do it? Why did it need that? I don't know. Okay, bug. Who knows? Yeah, I'm going to say it's the IDE. Let's blame the IDE. Okay, so here we go. Ready? We're going to do this from scratch. For the CircuitPython Parsec today, I wanted to show you how to use enumeration in for statements. So in a typical use case with a for loop, we're going to run through and, in this case, print out each item inside of a list. So I start out with this list called some cool letters, and I have A, B, C, D, E, F, G, H. If I want to use each item in that list, in this case just to print, typical way to do that is to say for I, a variable, in the range of the length of whatever that list is, length of some cool letters, print some cool letters, and then in brackets I. So it's going to go through the 0, 1, 2, 3, 4, 5, and so on. So I'll save that, and you'll see down at the bottom it's going to print A, B, C, D, E, F, G, H with a little pause in between. Now, that is a real common way to do it, but this is a much more elegant way to do it using enumeration. For a cool letter in some cool letters. So you can see here, we're not relying on I, we don't have any brackets, we're just simply going to enumerate through the items in that list with a cleaner syntax. So you can see we get the same result, it prints out each of those. Now, one other thing that we can do is also show the count, which initially will line up with the index, but the count of each item in that list is simply, in this case, the first item when we use enumerate in that list. So for a variable named count and a variable named a cool letter in enumerate the list, some cool letters, we're going to print out the count and the cool letter each time it runs through. So if I hit save now, you can see we get the 0, 1, 2, 3, 4, 5, 6, 7 count and their values. And so that is how you can enumerate with for statements inside of CircuitPython. And that is your CircuitPython Parsec. Hey, it takes a village. Thank you so much to the chat for solving the, or at least hacking our way around what could just be the IDE here. This is Sublime Text that I'm using. Some weird buffer flush thing, Mike P says. I like that. It could be a weird buffer flush. Buffer flush. Okay, we'll move on. I'll try that out on some other REPLs and serial outputs later. But one thing I want to mention is we've only got until I'm gonna end the show by 1:50. Sometimes I go a little longer than that. I'm gonna end at 1:50 today because Scott is going to, at least as of yesterday, he told me he was planning to do a deep dive at 2. From 2 to 4, so I will be sure to get out of there by then so everyone has some time, if you're watching that, to go grab a beverage and stretch your legs. Let's see. Question from the chat, actually. Let me bring up the Discord chat. Non-official says, hey John, what are your thoughts on the Seeed Studio Xiao SAMD21? I have used the Cutie Pie SAMD21, which is a very, very similar design based on the Xiao form factor. In fact, the whole Cutie Pie line, I don't know if you're familiar with these. These are the Adafruit Cutie Pie line. These are based on the Xiao. They are great boards. I love the SAMD21. It's a little underpowered for some more modern things that we like to do, but certainly a great chip for a lot of uses. Good for USB stuff. If you're doing HID things like joysticks and keyboards, really cool small board. So if anyone has experience with that specific board, let non-official in the chat know. All right. Okay, so next up, what do I have? Let me look at my notes here. We got gear report. Okay, I'll jump over to the bench cam. And let's throw, not that view, this view right here onto there. Let me jump over there. We're not going to look actually yet at this JLC PCB box, but I wanted to show, this is a brand new hype piece of gear. You may have seen it floating around the internet if you're into synthesizer-y kinds of things. This is from Teenage Engineering. It is their kind of evolution of the pocket operator idea. I don't have one right here. Pocket operator is a little calculator, handheld size. This is like a giant calculator looking thing. Gorgeous design. It's a sampler, so it can sample directly line in or on a microphone and then play out over its little speaker if you have to, or better, going through a line out. And you can trigger samples. So if I power this up, and in fact I'm going to turn on the microphone that I've got on that speaker, let me know if the volume gets kind of blown out if you can't hear me. Actually, I'll open up my Discord on the phone so I can see that. Not that, but that's right there. Yes, okay. So let me know how these levels are. This, so you can see I've got a bunch of drum samples on these 12 pads. If I go down to the next group, I got bass. Turn this up a little bit. And the way you use it typically is pick a sample you want, and then if you want to play it like a keyboard, either chromatically or with other scales, you can hit keys, and now whichever last one I pressed is now available as a playable keys. So you've got these 4 groups. You can sample into it. I'll show this off more once I'm a little more familiar with it. Once you have the samples loaded that you want to use, edited, you can then start sequencing them. I'll just show whatever I've got sequenced in here, some demo thing I made. So we've got the 4 groups at 4 different lengths. I've got like a 4-bar track. I've got, I think drums are just 2 bars. So that's the basic idea of that. Oh, good. C. Grover said the sound mix is good. It might have distorted a bit when I turned it up. Yeah, thank you. I think I cranked one fader. So super neat device. Lightweight, pretty portable, pretty stylish. 2 things I want to focus on today. 1, Lego compatibility. They made this with Lego Technic pin-sized holes on the side and spacing. So you can see this is a, I'm going to zoom in, fact, and focus looks pretty good. So you can see here I can put a Lego Technic pin. It clicks in there beautifully. I can put in another one next to it, and if you take any Lego Technic compatible object, you can click it onto there. So now you can start to make little stands for it, covers, whatever you want. The first practical thing I've built along those lines for it is using a couple of these Technic lift arms. These come in a couple of different angles. I can make myself a little angle stand for it so it's not flat on the table. I can instead click those in there, and now you can see it's at a cool little angle. There's another set of 2 down here. I don't know why they did the 3 up there and the 2 here. One of the guesses people have is that, much like the pocket operator, is a line of probably 12 or 16 different devices at this point, been out for a number of years. This may end up with, it's really likely this is a line and we'll end up with other, so this is the sampler, there might be a more drum machine specific focused one, other synthesizers, and they might click together with these little pins if you want to do that, or maybe there'll be accessories, who knows, MIDI controllers, I don't know. But anyway, that's the one kind of first thing I want to talk about with this cool gizmo. The other thing I wanted to talk about is Fadergate. So this happened really quickly, but these just came out, that people just started getting them in the last week and a half or so. And a lot of people, myself included, have had some problems with this fader. So you'll see there's a fader here that I'm using right now to change the level of whatever group I'm in. You can see if I touch it from the side, it is changing the values a whole lot, as if I've just slid the thing a third of the way. If I lift up or push down, you can see. So there are loose wipers on the little track, the conductive track inside of this potentiometer. And so people have been taking these apart, pulling the fader apart, pushing those little spring-loaded track or wipers down, and then fixing the problem themselves. You can send it in for a warranty, RMA, or repair. However, these things are kind of back-ordered, and if you want to keep it, your main choice right now is either ignore it, if you can, or fix it yourself one way or another. Some people have not been able to use their devices because this is like constantly moving and taking over the screen and everything if it's super, super broken. Issue may be with a bad batch of slide pots. It could be a problem with the packaging, which was super, super tight. At first, people thought it was the knobs that they have you put on yourself, but I suspect it was more of a shipping problem than anything else. So I'm not going to fix mine right here, right now yet. I'm not sure yet what I want to do. Mine actually, if I only use it with downward pressure, it seems to be pretty reliable. You can see when I let go, it kind of stays there. If I go from the side, I can make it jump. If I wiggle it, that's no good. But I can kind of use it, and I kind of want to have it to use for now. I'm not sure how many days you have to call in and say you've got a problem, but I'll look that up. So the one thing I did want to do, though, is take a look at inside of a typical slide potentiometer to see what has happened, what has gone wrong. This is a slightly different design, but by and large, pretty similar. So you can see here, slide pots have a little PCB at the bottom, and we've got, and I'm sorry, I should have unbent these. Oh, I got to find a better, thinner tool. Will you work? Yeah, that'll work. So these little tabs wrap around from the metal outer casing and hold the whole thing together. And so the fix for people who are willing to do it has been to desolder their slide potentiometer on the KO2 and then do this, pull these, okay, I got to get a little tiny screwdriver instead. So yeah, they've got to desolder it from the board, then pull it apart, then bend those little wiper blades down, and resolder it. I'd considered doing it on air, but I decided I'm not quite ready to take those steps with it. And one thing I've heard from people who've taken it apart is there's something like 28 tiny little screws. So I don't know if I'd want to do that as a fully on-air experience unless you really love watching someone with a screwdriver. So let me know in the chat if you'd want to see that. If I do opt to do the fix, you know, it's a small manufacturer. You cannot get, they can't suddenly make a zillion more of them. I don't think they were prepared for this, so it could take you a long time to get your replacement is the problem. Okay, so there's 2 left. We're so close. Thanks for your patience in watching this. Yanisku7 says that it's like it says koi. Yeah, it stands for knockout, KO. That's why today's coupon code, if you want to get 10% off in the store, is knockout. And they've got like some boxer-themed icons on here. One thing, by the way, I should also mention is, man, this thing has a neat display. It is, I believe, colored LEDs under LCD, a custom LCD, and then this one is a matrix, a typical matrix module. But most of this, if you look at, let me play. You can see some of those coming on there. This is all static. This is not a TFT screen. There, that's a good one. You can see them blinking on and off. Those are old school LCD style. Those are always that object, that graphic in that position. It's not a TFT, which is partly, I think, why they're able to make it so fast and responsive on a fairly modest microcontroller. I think it's a Cypress chip in there, I forget which one, and keep the price down. So that's a pretty cool. Okay, here we go. I've got all those tabs unbent. Oh, no, I don't. I missed one. Savant42 says, at least hoping we can source the OEM slide potentiometers. No sense in resoldering a dodgy component. Yeah, it's a good point. I think they've got a fairly custom-looking stem because they designed it to fit Technic's pin. And you can see this is kind of just a loose fit on a typical Alps-style slide pot. They've got like a plastic compression fit component there. They may have done custom, or I've just not seen it before. Okay, so here comes the housing off of here. Try to keep everything else intact. So outer housing there has just a little dust guard on it. This is a little sort of low friction piece of plastic of some kind. Maybe it's nylon that helps that slide. Then we have the actual, in this case, there's a spring that I believe helps this thing, prevents this thing from wobbling. The spring doesn't make any contact with anything. It's just like a little leaf spring kind of guy. Let me grab some tweezers. That pushes that little plastic or nylon component up against the shell. Then this is the actual slide with the wipers. Let me see. Can you hold that? Sorry. Yeah, there we go. So this is the resistive element, and we're just adjusting the resistance depending on how far away from one end or the other we are with this. So these are what we think are faulty on the KO2, is these little wipers here. So if you look at those, if those, which are spring-loaded to touch the track, if those have been damaged by pressing them down hard, and possibly that's what's happening in the tight packaging, then they just may be flaky about actually contacting the conductive track. So what people are doing is just giving them a little help like that, unbend them just a little bit so that they want to always maintain contact with the track. That seems to be the fix. That's worked for a number of people. Some people have also come up with ideas on trying to make the repair while everything is still assembled by essentially using a little pick to reach in there, like a little bent pin. Sorry, I keep going off screen with that. Try to reach in there and push down, but you're never going to get that levered beyond the bottom out. So I'm not so sure how much that might just be putting a little strain on the spring. That has worked for some people too, but I don't think it's a dirty contact. I think it's just a squashed spring. So anyway, that's the one issue with that. But I wanted to show off the cool new gizmo, and love that Lego compatibility that they've put in there, especially if you have lots of Technics and Mindstorm stuff laying around, which I do. So build some fun stuff with that. Okay, that is gear report there. Let me turn down that speaker, and then we'll talk about the PCBs came in for Faderwave. Let me take that mic down, come back here for a second. Yeah, Savant42 says your fader is wonky. Yeah, mine's a little wonky, unfortunately. Not super busted. Some people have had rattling around parts kind of busted, but yeah, it is a cool piece of kit for sure. If you're interested, look, there's some people who've done some teardowns on YouTube, so you can see the guts. There's some nice light pipes or guides. There's a board of LEDs that are lighting, backlighting all of those graphics. It's a neat looking design. They did sell out quickly. Thin Man. You can look at Guitar Center and some other big online or local retailers. You may find it in a local Guitar Center. They had a lot of them. It's hard to find it online at a fair price right now, though. People are flipping them. Okay. P. in a hurry. Am I going to Mindstorm up the KO2? I don't know if I'll put motors on it or not. I was thinking of adding some wheels, but that may be a bad idea. Okay, so let's talk about Faderwave. This is, what do I have to, I don't think I've got an easy way to show PCB design other than the PCB themselves. So these came in. Let me show you and talk about them here, and then I'll do it on the overhead and give you a demo. So this is my version 0.1 PCBs that came in. Let me get that view off of the camera. I'm going to go to the overhead. In fact, right here. Let's do it this way. Do a little focus. There you have it. It's a little bit of glare, but that's it. Yeah, so it came in. This is 16 slide potentiometers. In fact, the exact one I just took apart there. It has a double row of pins here for socketing an Itsy Bitsy, so you can use the Itsy Bitsy M4 or the Itsy Bitsy RP2040. Itsy Bitsy M4 is coming back in stock, by the way. We're out right now, but those are coming back. We finally have those M4 at SAMD 51 chips, so those will be back. And those have a analog audio out the DAC stereo, 2-channel, A0 and A1. So that's what I've got wired up here, but you can also use those two same exact pins as a PWM out on the RP2040. And then that runs over to a little RC circuit here. Hold on, I'm going to keep noodling with the focus just a bit. Yeah, that's pretty good. Is that dark? No, that monitor is dark. So that output goes to a little stereo TRRS out. We only need the TRS, but that's the breakout that we have. Then we have the two ADCs. They're a pair of 8-channel ADCs on I2C, and those read the two pairs of 8 faders. So all 16 faders are read there, and their positions are sent over I2C. This is a DAC output, so if you want to use control voltage with a modular synth, maybe turn this into like a sequencer of some kind, that is your nice DAC output there. Liz is thinking of doing a project with this, so we'll hopefully get some cool code out of that. I put a little SPI OLED display on here, a rotor encoder with the click wheel, so a little more UI, and then this is where the RC circuit is. So that's the original one. Not too fancy. I didn't do any kooky silk screens or anything, but they came in, and I put them together, and they work. I put one together in stages, so I didn't want to solder everything down until I knew it was working, but that's the populated board right there. And so you can see I've got my Itsy Bitsy. I have that socketed, so I've tried both the M4 and the RP2040. They both work. You can see here I have this second row of pins, so I can solder down a second row of these headers in case I want to be able to prototype stuff by plugging into pins that are not used. So this was a suggestion Lamore had, just to make it possible for people who want to maybe use an I2S amplifier or something, and they just want to get at some pins that aren't routed. And so yeah, you can see I've got my ADS 7830 ADCs, I've got the DAC, I've got the OLED. You can see on the DAC we have I put a little pigtail there with a mono 3.5 millimeter jack, so I could test getting control voltage out of that. It works. And then I've got my push encoder, and there's my little RC circuit output. One of the revisions that I'm making is, on Lamore's suggestion, the ability to bypass the RC circuit and go straight out if you're using the M4 version, so I've added some little sliceable jumper pads so that it'll reroute the way you want it to. Thank you, Todd. Todd said it looks cool. So I've got temporarily just some M3 nylon standoffs, so it has feet, but I'll be designing a proper cover, faceplate, case, something like that. Could be a PCB, could be a laser cut thing, could be a 3D printed thing, but we'll try a couple different options there. And so what does it do? Let's, you know, let me demo it here. This is actually working pretty well. So here's what I'm going to do. I'm going to give it power. Is that power? Yeah. Okay, so a few things light up. You can see I've got something on the screen there, not too much happening with the screen yet. And I'm going to turn this just a little speaker here back on, and it'll announce itself, and I'll plug that into the little TRS output there. And I'm going to adjust the focus one more time since we're now looking at parts and not the PCB. It's a little taller. So what I'm going to do is just send it MIDI. So the idea behind this thing, if you are wondering what even am I doing with it, yes, you could turn it into a sequencer or a controller. What I've got it doing, this is the idea that Limor had me look at a project that was existing that was called the reverse hardware oscilloscope. And the basic idea is when you're making a waveform, you can look at the shape of that wave on an oscilloscope. What if you could just dial in the shape of one cycle of that wave that's repeating and being repitched with faders? So if we want to do some sort of a sine wave, we could shape it like this. If we wanted to do a triangle wave, like this. If you want to do a square wave, like this. And that is exactly what it does. So I've got SynthIO, and in SynthIO you have the ability to specify the individual points of an array, which is the waveform. So that's why this exists. So I'm going to start out with just something like that, and I'm going to grab this microphone actually. Let's see if I can just place that over there. Just because that little speaker is not going to get picked up on my lavalier mic so well. Okay, so I've got the speaker itself has a loose TRS connection, unfortunately. All right, so I'm going to place the microphone here. Hopefully you don't get a lot of rattling, and I'm going to turn up that volume. So now what I'm going to do is send MIDI notes to this over USB, and SynthIO running on this is actually what the synthesizer is. That's the synth that we'll be hearing. So I'm going to just send it some MIDI. Here it comes. Ooh, some gate. And I'm hearing nothing. Oh. This is this flaky speaker. Darn it. Come on, thing. There we go. Okay, I'm going to give that a moment to play so that we can determine how the mix is sounding, so that you can hear me explain some things as well as the music. So I'm just going to give that a moment. Let's see. Oh, Andy Lear, I just saw your message over in the chat. You're listening to this show running through the input of your KO2. That's awesome. Using reverb. I love it. let's see. Jim Hendrickson, I see you typing. Are you going to tell me how we sound? Just that your cat likes them. Okay, I'm gonna hope that you can hear me. So you can hear this certain type of round, mostly fundamental tone. Thanks, C. Grover. Sound mix is good. What I'm going to do now is just have you listen. With each new note, currently the software will use the updated waveform. I don't have it running on a continuously playing note yet, but the next note that plays, you'll hear a change in that sort of harmonic timbre. Okay, so it almost sounds like I'm using EQ or filter or something, but really what it is this is the shape of this single cycle waveform. Now emphasizes certain harmonics, higher harmonics than it did previously. Let's do a okay, so this is a waveform that just has a little blip in it, and as I get smaller, the waveform kind of basically goes away. It just doesn't have that much sound to it. There you can see picking up some of that higher stuff. One thing I want to do real quick is just see if I can loop that. And I'm going to pick up the rate a little bit. Okay, I'm going to pause that and show you what is actually changing when we do this in code. So let's jump over to the code view. I can hide that window there. And let's open up the code that's running right there on that itsy bitsy. That is not it. I've got to unplug the other KB2040. Okay. There we go. That's the itsy bitsy. So I'll go over some of this in a little more detail in a second, but what I just want to jump to first is what's changing. And it is this right here. This waveform called wave user is a NumPy array, and it has 16, since I have 16 sliders, it has 16 values in it. And so if those values are shaped like a sine wave, that is the type of warm, round sound that we get. As you can see right now, this note on, that's what's happening when a MIDI note is played. We're calling note on in synth.io. It says right here, synth press, synth.press voices. The voices in this case are, I think I just have one. You could do stacking of them to get some cool detune, but I wanted to just focus on the one note or the one voice. That array right now, this could probably be optimized, but right now you can see I just have 0 through 15. So those are my 16 faders. Whatever the fader value is getting remapped from 0 to 123 to negative. So the waveform goes below 0 and above 0. So negative 30,000 roughly gives us a little dead band at the top and bottom. Negative 30,000 to positive 30,000. That's the range that array that is the waveform can occupy. And yeah, so Seagrove says, looks like the middle of the fader setting is the baseline of that waveform. That's right. The other things I want to show you, so just in general about the board, right now I think I have, I'm going to turn, let me see if I can kind of quiet it just by throwing these down here. I'm going to play notes into it again, and you should see whoops, not there. You should see right now, I'm just printing the number of the note, the MIDI note number right now. So 62, 53, 60, 62. So this is playing these little noodly melodies based on some Turing machine-like randomness. So that's all I'm using the display for right now in code. What I'll do is look at some commented out stuff I was doing during testing, and you'll see, for example, let's see, what does this one do? Okay, so fader 1, I'm just remapping the values right now from 0 to 255. Fader 2, fader 3, fader 4. I'll go to a full view of that. So this was useful just in testing. Did I get everything put together right? Have I coded those little ADCs properly? So that lets us know when one of these values changes. And it's pretty stable too, which is nice. I don't have a lot of code in there to avoid jitteriness, but it's they're good faders, and that's a good ADC. So it is pretty stable, which is great. You can see if I wiggle one, we can get it to, wiggling faders is never good, right? David S. asks, could you develop the software to show the waveform on the display? It's an interesting idea. What I found is that this display will cause some little interruptions to the sound. So I think the combination of the processing cycles that we have, the fact that we're doing audio stuff, and then trying to write to a screen. I was noticing some, especially if I make the type bigger, the more pixels that are being changed on screen, the more I'm getting glitches and stuff. So that'll be an interesting area to see if we can fix. And I was also doing some tests with like the rotary encoder for that. One test I have on the rotary encoder right now is just it plays a note. And while I hold that note down, listen to the sort of little chatter we'll get when I'm updating the display. All those little da-da-da-da, that's because the display is changing. If I, let's see, do I still have, I think yeah, so let's make the scale big. So the more pixels we're trying to change, even though some of them are off the screen, you can hear more. Totally neat for like a weird glitch instrument. Todd says also that the chatter is because of all the I2C traffic you're doing. If I stop updating the screen, let me get rid of this note on message right here and the note off message. Let's see, will this stop updating the screen? Yeah, okay. So you can see that by not updating that screen, that problem goes away. So could be some problems in my PCB design. Maybe there's some filtering I can do, but it's there. One of the ideas behind this is that if you want to build one of these, you can just use it for a whole lot of different purposes. Just having a ton of faders and these couple of outputs and a display and one more extra, like maybe use this encoder for scrolling menus and picking settings or whatever. Kind of a fun platform for doing stuff. Let's see. Oh, Todd also says increasing the audio mixer buffer to 4096 could help a bit too. Oh, interesting. All right, I'll try to remember that after the show. Thank you. Other questions. Andy Lear says, this is cool. Need an alternative sketch for it to be a MIDI controller for a Hammond organ VST for the first 9 bars. That's cool. Yeah, I like it. I'm excited to see what Liz does with CV. So we've got control voltage coming out of here, and this could be interesting for things like a sequencer. We're not going to get 16 CVs out, so it's not that kind of thing. For that, look at the 16N project, 16N as in Nancy. That is this sort of thing, but really purpose-built for using with Norns and Eurorack and MIDI and I2C. It's a very specific gizmo that's really well designed for that, and it's also open source. Right. Let's see. I said I was going to end 7 minutes ago. Look at me go. I better stop right here, right now. So that's the state of that. I'm doing the revision, and once that's out, I'll put together the guide, and you can go grab one, build one yourself. Jeff asks, is Scott coming on? As far as I know, but I've only spoken with him yesterday, so I haven't double-checked yet. Let's see. Last things I'll do are mention, there's our coupon code. If you want to get 10% off in the store, type in Knockout on your way out. That'll get you 10% off. And remember, you get those different freebies at the different price points of $99, $149, $199, $299. Is that right? I may have made up some 99s there. So anyway, slice it. That'll get you 10% off on your stuff from the Adafruit store today, excluding software, gift certificates, and subscriptions. Oh, hey, and Scott is here, so I better run. Yay. Thanks, Scott. Scott is up next with a deep dive. So go grab a beverage and walk around for a second, and then tune in for that. That's going to do it. Thanks, everyone, so much for stopping by. Yeah, have a great weekend. Have a happy rest of your Friday. For Adafruit Industries, I'm John Parker. This has been John Parker's Workshop. I'll see you next time. Bye-bye. You got